Hello everyone and welcome back to my channel. Today we are diving into a method that is sharp, swift and doesn't even need derivatives, so it's a secant method. Whether you are tackling some nonlinear equation or optimizing your numerical toolbox, the secant method offers a simple yet powerful alternative to Newton-Raphson method. We will implement this secant method in MATLAB step by step. So let's get started. So for the development of the secant method code, we need the following things. Number one, we need to define our nonlinear function. And in that case, we are choosing x cube minus 2x minus 5. Secondly, we need to set the two initial guesses, that is x naught is equals to 2 and x1 is equals to 3. After that, we need to apply the secant method in order to find out the root. So for that, we are using the while loop. Next, we need to check the convergence based on the tolerance. So that should be 10 raised to the power minus 6. After that, we are going to plot the function. And finally, we need to display the final root and its results. So let's move to the MATLAB. Okay, so this is the interface of the MATLAB and we need to just click on our new script. So an editor pop up in front of us and we are going to develop the code of secant method. So this is our secant method script. So initially I'm going to start it with CLC, clear all and close all. After that, we need to define our function. And here we are choosing f is equals to at the rate x and the function should be x raised to cube minus 2 static x minus 5. That is our function that we are choosing. After that, we need to define our initial guesses. So the first initial guess is x naught is equals to 1 and the second one is x1 is equals to 3. Sorry, we are choosing x naught is equals to 2. That would be our first initial guess and this would be our second initial guess. Okay, after that we need to define our tolerance and here I am choosing 1 e raised to the power minus 6. So that is basically the tolerance for convergence. After that, we need to define the max iteration. So here I am choosing max iteration to 100. So that is basically the maximum number of iterations. After that, we need to initialize our variables. So we are just initializing iter, that is 0, that we are going to use in the loop. So that is basically the used as an iteration counter. After that, we need to write down the loop. So here is secant method loop. So I am choosing a while loop. So for while loop, I am choosing iter must be less than max iteration. And initially, I am going to compute the first approximation using the secant formula. So compute the next approximation using the secant formula. So the secant formula should be x2 is equals to x1 minus f of x1 static and we have x1 minus x naught divided by f of x1 minus f of x. So that is the formula of a secant method. After that, we need to check that if the result is within the tolerance or not. So check if the result is within the tolerance or not. So for that, I am using if condition, that if ABS, that is abs x2 minus x1, that should be less than tolerance. So after if statement, I'm going to use my AND, and in between I have to print, so f print f, and root found at x is equals to percentage dot 6. I'm using here dot 6 because we need to check the tolerance to 10 raised to the power minus 6. So that's why this will display the number still 6 decimal places. So after percentage d iterations dot backslash n, and we have to show x2 as a result, and the counter should be iter plus 1. So after that, it break it, and then we need to end it. After this, we need to update our variable for the next iteration. So we have x naught is equals to x1, x1 is equals to x2, and finally we have iter is equals to iter plus 1. So that is basically increment the iteration counter. Okay, that's it in the while loop. So after that, we need to check that if the method did not converge within the maximum iteration. So for that, we need to use an if statement. So if iter is equals to max iteration, so the print for us that method did not converge after percentage d iterations dot backslash n, and we have to max iterations. Okay, after that we need to go for some plotting commands. So initially we are going to plot our main function. So plotting the function. So for that we need to define our x and y values initially. So x values should be linspace, and that is 1 to 4 to 100. So that will basically generate x values for the plot. After that, we need to generate the y values. For that, we are using array function. So array function, we have the first function, that is our nonlinear function, and we have x values. So that will basically evaluate f of x for each x. Then we need to open our figure, and after that we need to plot our main function. So x values versus y values, and we are just defining the color and the style, and the color should be red and the style should be a solid line. After that we need to define the line width, that is totally optional, it's according to your choice. So we need, this will plot the function f of x. After that we need to use hold on, and we need to plot the roots. So we have x2 versus f of x2, and we have to choose the color and the style. Color is blue and style is circle, and as we are using a circle, so we need to define a marker size just to prominent it. Marker size should be set it to 10, and the marker face color, that should be fill this circle. So we are just choose the color of the marker face is blue. So that will basically plot the root. After that we need to just customize our plot, and for that we need to define the x label, and for that I'm choosing x. Then we need to define the y label, so for that we are choosing f of x. After that we need to define the title, so that is the MATLAB code for secant method. After that I want to on my grids, and finally we need to define the legend. So the first is of f of x, that should be our red line, and then we have a root, that should be our filled blue dot. Okay, let's run it. This is a secant method. Okay, we need to fix our error first, and we have an error in legend, so L should be small. We need to run it again. Okay, so finally we found our root at x is equals to 2.094551 after 6 iterations, and this should be our graph of secant method. This red line represents the function, that is our f of x, and this blue dot represents the root that we found by using a secant method. And that's it. If you found this video helpful, be sure to like, subscribe, and hit that notification bell so you don't miss out any numerical techniques that is coming your way. So drop your questions or feedback in the comment. I would love to hear from you. So thank you so much for tuning in. I'll see you soon in the next video. Take care.